Hello everyone, myself Dr. Feroza D. Mirajkar, and today we will see a 8051 program to transfer 10 bytes of data from external RAM to the internal RAM. Here the purpose of the program is to copy 10 bytes of data from the external memory starting at an address 0040H to internal RAM starting at address 30H. So these are the steps for the program. That is, first we have to initialize the loop counter and the pointers. Next, we have to use a loop in order to transfer data byte by byte, and then we have to halt when the program or the operation is complete. So here I have written 0040H. This is for the external memory. Okay, this is for the external memory location. Here this is a 16-bit addressing for the external memory, and the 8051 microcontroller, it uses a 16-bit address for accessing external memory. So a 16-bit address, it will allow the microcontroller to access a memory range from 0000H to FFFFH. And when you write like a 0040H, you are explicitly specifying the full 16-bit address and writing just 40. That is, instead of writing 0040H, if we write only 40H, it would imply an 8-bit address, and which is it is insufficient for external memory operations, and the assembler would interpret this as an incomplete address and could result in an error or unintended behavior. Okay, so now we'll start with the program. So here I will be storing 10 data, okay, at memory locations 0040H up to 0049H. So this is the 16-bit address, that is the external memory address. Okay, and we have to copy the program, we have to copy the data from the external memory location to the internal memory location, that is 30H, 31H, 32H up to 39H. Before execution, here at these locations we have all the data as 0 because yet the data has not been copied here. Now after execution, the data which is present at the memory location starting from 0040H to 0049H, it will be copied to the memory locations 30H to 39H. And here these are the external locations and these are the internal memory locations. And here the data which is present at 004H, that is 11, it will be copied to the internal memory location 30H, that is 11. Similarly, 22 is copied to internal memory location at 31H. Then 33 is copied from 004 to H to 32H, and so on up to 0049H to 39H. Okay, and here we have some key points for the program. First is we'll be using here move x instruction. Here in order to access the external memory, we'll be using move x to interact with the external memory pointed to by the DPTR, and in order to access the internal RAM, we'll be using move, which will write the data from the accumulator A to the internal RAM. Okay, internal RAM address which is pointed by R0, and we'll be using the decrement jump if not 0, that is the loop control, to decrement the counter R2 and check if it has reached the value 0. Okay, and this is the program. So as usual, we'll start our program with the org 000H, which will set the starting address of the program. And the next instruction is, that is the first instruction here, it is move R2 comma hash 0AH, which will load the value 0AH, that is 10 in decimal into the register R2, and this will serve as a counter to repeat a process 10 times. Okay, first instruction. Then next, here we are using the register. Here next, like we are using the register DPTR. Okay, that is the data pointer register, and this instruction, it will load the data pointer register DPTR with an address 0040H. Okay, and this points to the source memory address where the data is stored. Then next is move R2, sorry, move R0, comma, hash 30H, and here this will load the register R0 with the value 30H, and this is the destination memory address where the data will be stored. Okay, so here for internal RAM, uh, like we are using this one, move R0 comma hash 30H, and for external memory we are using the move dptr comma hash 0040H. Okay, and here external memory, it always use 16-bit addressing, and this is where dptr operates. Okay, and external memory is typically accessed via move x instruction. Here move x instruction, and which will rely on the dptr to specify the full address. So once we have done with the initialization process here, that is we are initializing R2 dptr, the location for dptr, that is the uh, which will point to the source memory address. Then we have done with move R0 comma hash 30H, that is the source destination memory address. Then we will go to the main loop. Okay, this is our main loop where we have given a label called as up here. Now here in this loop, the first instruction is move x a comma at dptr. This instruction will read the data from the external memory location pointed to dptr, which is starting at an address 0040H, and it will store it in the accumulator. Okay, so what it will do, this instruction, it will read the data from the external memory location. Okay, from the external memory location pointed by dptr. This, it is pointed by dptr starting at address what, 0040H, and it will store that in the accumulator. Then next instruction is move at R0 comma A. This will transfer the value from the accumulator, okay, from the accumulator A to the internal RAM address pointed by R0. That will be starting at 30H. Okay. Then what we'll do, we'll increment R0, that will increment R0 by 1, pointing to the next destination address in the internal RAM. That is, this 30H will become now 31H. Then increment dptr. This will increment the dptr by 1, pointing to the next source address in the external memory. So this dptr now becomes 0041H. Then it will go to the next instruction, that is djnz r2 comma up. Here it will decrement the counter R2 by 1. If it is, that is, if R2 is not 0, the program jumps back to the up label, then it will repeat the process. Okay, earlier here R2 was 0AH. Fine. Now again it will check it. Again it will go to the label up until and unless this R2 becomes 0. Here it was 0AH. Earlier it was 10 at starting of the program. Now we have decremented it by 1. So it will become, R2 will become what? 9. So again it will go to this label. Then again it will execute this loop. Now when it goes for the second iteration, R2 will become what? 8. Third iteration, it will become 7, and so on. It will continue until and unless R2 becomes 0. So this loop copies what? It copies 10 bytes of data from the external memory starting at 0040H to internal RAM starting at 30H. Now this label h, that is we are halting the program. Okay, that is the endless halt. Here this s jump h, it is an infinite jump loop. Sorry, it is an infinite jump to itself, that and effectively halting the program, and the microcontroller will stay in this loop indefinitely after completing the main task. Then this end statement, it will mark the end of the program for the assembler. So here these are the values which will be using as an input before execution. That is at memory locations 0040h to 0049h we are having these data, and at 30h initially we don't have any data, all are 0. Then after execution we'll be having this data, that is the data which was present at 0040h, it will be copied to the internal RAM location, that is 30h to 39h. So this is the step-by-step execution of the program. First we will initialize R2. Okay, R2 is equal to 10. Then R0 is 30h. Okay, then DPTR is 0040h. Then we have to go to the main loop. We have to start the loop. We have to read the value from the external memory address pointed to by the DPTR, and then it will store it in the accumulator. Then we have to write this value to the address 30h. Okay, that is R0 in the internal RAM. Then increment the DPTR to point to the next byte in the external RAM, and increment the R0 to point to the next byte in the internal RAM. Then decrement the loop counter R2. Okay, and this loop will execute 10 times until and unless all the 10 bytes of data are being copied to the internal memory. Okay, internal memory location. Then step 3 is repeat until R2 is equal to 0, that is it has to complete 10 iterations in total until and unless R2 becomes 0, where we have initialized R2 as 10. Step 4 is enter the infinite loop at the label h. Now we will execute the program. I will copy the program from this slide. Okay, now we will open the Keil software. Maximize this. Go to the project, new Vision project. I'll use the previously used project, Alice. Yes. Now select the microchip device and click on this plus symbol and search for 8089 C51 and click on OK. So copy startup.A51 to project folder and add file to project, click on no. Now go to file, new file. You can write your program, that is you can type your program here. I'll directly paste the program, then I will save it. I'll name this as external to internal dot asm, ext to int dot asm. I'll save this. Okay, next you have to see whether the target has been created. So it has been created. Click on this plus symbol. Now go to source group 1, right click on this and click on add existing files to group source group 1. Then search for your program. It is external to internal dot asm. Click on add and close. Now check whether the program has been added in the source group 1. Click on this plus symbol. So here you can see your program has been added to source group 1. Now go to the project and click on build target. Okay, so you can see here 0 errors and 0 warnings. Now go to debug and click on start or stop debug session. Now click on OK. Okay, so here we need two memory windows. So one will be 0040h and another will be for 30h. So memory 1, it is from external. So whenever we are going for the external memory locations, we have to type x colon 0040h. Okay, and we need one more memory, so we'll go we'll select it from here directly. Click on this, select memory 2. So memory 2 will be internal memory location. So it will be I colon 30H. Okay. Now we will enter the data at the external memory location. So I'll give it as 1, 2, 3, 4, 5, 6, sorry, 7, 8, 9, and 0A. Okay, you can give any data of your own choice. Now we have to check whether it will be copied to this or no after running the program. Again, go to debug and run the program. So you can see here earlier at 30H you were having 0, 0. Now it has become 1, 2, 3, 4, 5 up to A. That is the data which has been which we have given the input at the memory location starting from 0040H to 0049H. It has been copied to the internal memory location 01 memory location starting from 30H to 39H. So the data has been copied here. Okay, so this is your program, how you execute. Now we'll stop it. So here this program, it efficiently moves a block of 10 bytes from external memory location, that is starting at 0040H to internal RAM starting at 30H, and then halts the execution. Okay, hope you all have understood the program. Thank you.